All right, record. Wait, what test are we taking? Is that summative? No. We'll be successful when we can determine extrema from a sign chart of the derivative. So we use this graph in 3.1, and we also use it in pre-calc a bit, but we found out local extrema the other day on here. So what local extrema do we have on this open interval? Well, there were 3 of them that we found. There was 2, we checked out the global and absolute extrema as well. But in particular today, I want to look at the absolute, or the local extrema. There was 1 local minimum. There wasn't plural, which would be minima. There's a single minimum. It was right there. Local maxima, there were actually some more of them, 1 of those. There was 1 right there, and there was 1 right there. Okay, so here's what I'd like you to do is take 2 minutes to make a sign chart of the derivative of this graph. So because I can't see any of your screens, here's what I envision you looking like when I ask you to make a sign chart of the derivative of this graph. Let's talk about what a sign chart is. It's literally a number line. There are some other other ways you can make it where it's not a number line, but I like making the number line because I think it's simple and efficient. But basically what a sign chart is, it's scratch work to help us think about the sign, S-I-G-N, of a function, its derivative or second derivative, or really anything. It's just a way to help us think about the sign. I don't care what the numerical value is. I just care whether it's positive, negative, 0, or undefined. All right. So this is how I would start making a sign chart. I'm going to label this one with F prime. Here's my line. Now there's more I'm going to do with that. So let me show you. So this is all coming out at once, and I was going to fix the animation, but I never did. So let's say I have f of x equals x to the 3rd minus x. F prime of x would be 3x squared minus 1, just doing some quick derivatives. Here's how I set up the sign chart. Is to do, I label the chart, draw my number line, I label it with what function I'm using. So I could do f, I could do f prime, because those are the only things I'm dealing with, but I particularly today want f prime and see what that is. I'm going to put different inputs on the bottom and outputs on the top. So the inputs, these vertical lines, those represent times where the function is, or the particular function I'm dealing with is either 0 or undefined. And if I look at the derivative, it's 0 at 2 spots. At negative 1 over square root of 3 and positive 1 over square root of 3. And you can get that if you just set f prime of x equal to 0 and solve from there. Alrighty. Well, since they're both 0, the output at each of those spots, it's 0 here and 0 there. Now what I'd like to do is I'm going to plug in numbers on each of these intervals, because I all of a sudden have created 3 different intervals. 1 here, 1 here, and 1 here. What I'm going to do is plug in a number, some random number, any number in that interval, and see if it's positive, negative, 0, or undefined. So let's look at this first interval. I'm looking for a negative number less than negative 1 over square root of 3. How about negative 10? If I plug in negative 10 to the derivative, 300 minus 1, that sounds positive to me. Let's pick a number between negative 1 over square root of 3 and 1 over square root of 3, which, I don't know, I'm going to say 0. I mean, it could be an a-hole and say like 0.127538792222226. But that doesn't make sense. Let's just pick something easy, like 0. I plug in 0 to this, I get negative 1. So this whole interval, everything in the interval is going to be negative. Let's pick a number larger than 1 over square root of 3. Say, let's see, I did negative 10 over here. Why don't we do 7,000 over here? So you plug in 7,000. I'm getting like 129 million, something like that. Minus 1. So that's positive. So everything on this interval is going to be positive. Boom. You've just made your first sine chart. So this is something to note. The sine charts we're making, there's more than one way to make a sine chart. And because there's so many different ways to make a sine chart, College Board does not count it as justification work in and of itself. It's scratch work, which means they don't grade it. So you can do it all over the page, whatever. The important part about this is you interpret the results. Again, it's SIGN because I'm looking at the sign of the number. Is the sign positive? Is the sign negative? Or is it 0 or undefined? That's why it's SIGN. So that's a very good question. Thanks for that. Why is it SIGN instead of SINE? Now, it'd be really weird if we had to do a sine chart of sine. That's just more than I need to do to you right now. But that's the whole idea of the sine chart. Sorry, my right ear is a little plugged up, so that's why I keep digging in there. I'm like, come on, get out, get out, get out. It feels like there's something in there, but I can't get anything out. It's super annoying. Okay, so that's the sine chart. Let's do another sine chart. So here's another way to do the sine chart. One way to do it is if I have the equation, I can just plug in values and see what happens. Another thing I could do is if I had a graph, I can make a sine chart from a graph because the sign of the derivative is the slope at each of those points. So I went ahead and I identified some spots where the slope is 0 or undefined. So I have, let's see, 1, 2, 3, 4, 5 places. Of those 5 places, 3 of them are 0, right? Horizontal line, horizontal line, horizontal line. These two, at this point and this point, I tried to get this one to match up better, and it just was a pain in my butt and just didn't want to work. Those both don't exist because they're sharp points. They're not differentiable at sharp points. And here's your reminder of that. Again, it's not differentiable because it doesn't smoothly go to something else. If you look at the slope of, right here, the slope's about -1. Instantly, it becomes 0. So at this point, it instantly changes. There's not a smooth transition. The derivative don't exist there. Therefore, it's not differentiable. So it's continuous here, but not differentiable. Fun facts. Okay. Now what we want to do is we're going to look at each of the 6 intervals, which there's 6 intervals there. And we're going to look at, is the slope positive, negative, 0, or undefined? So in this first interval, anywhere on this, if I drew in like a tangent line, or honestly a secant line too, it'd be positive, right? Again, any point on there, if you draw on a tangent line, the slope's positive. This is the next interval I have to deal with. On that interval, the slope is negative. This interval, the slope is 0. This interval, the slope is negative. And this interval, the slope's positive. This interval, the slope is negative. Cool. We made a sine chart from a function, from an equation on the previous slide, and we just made a sine chart from a graph here. So we mentioned that this is an extrema right here. And then we have 2 others. There's one down here and one down over there. So it's not a question right now of if they're extrema. We know they are. We know 2 are maximums, 1's a minimum. What happens right here to the sine chart? What happens right here at the sine chart? What happens right here at the sine chart? I'm going to just give you 30 seconds to think because I want you to think about that. I don't want to say anything right away on this. So I got a couple people private message me some ideas. The one I want to highlight is it's a change in the direction of the graph. Yeah. Because it goes from positive to negative. That's a change in direction. Over here, it's negative to positive. Change in direction. Over here, it's positive to negative. Change in direction. That's the big idea. Now, that is the first derivative test. We haven't even got to the first derivative test, but we're going to look at it on the next slide, Joe. Oh, not on the right thing. Everything here on the right-hand side is my summary of the first derivative test. There's a lot, and a lot of it isn't necessarily groundbreaking or earth-shattering. It's just like, oh, okay. So I want to point that out, though, is so f prime of x. So everything in that's highlighted is something that we can determine. And the thing immediately below it that's unhighlighted is how we determine it. And everything here is the first derivative test. So if I want to show f of x is increasing, I need to show, if I want to know if f of x is increasing, I need to show f prime of x is greater than 0, is positive. If I want to find out if f of x is decreasing, then I need to show f prime of x is less than 0, that f prime of x is negative. If I want to find out if a critical number is a maximum, then I need to see the derivative change from positive to negative. Now that's how you can also look at that in the sign chart, and that's why I like pointing out the sign chart, because you can see that there. Now notice, if you haven't noticed, like I emote a lot just because that's how I am, and I really like talking with the hands. And if you watch, oh, you probably haven't watched it. I've made a lot of pre-cook videos this year, and I'm not talking, my hands are talking. It's a lot of fun. You can tell the difference because of the different colored rings. But the thing I want to point out here, if you go from positive, do a positive slope with your hand, do it with me. So do it with me. No one can see you, so you might as well do it with me. Positive to negative. That's a maximum, bro. That's what I was looking at right here. Positive to negative, maximum. And look, there's a handy dandy little helpful tool right down there. You can see that picture has a positive slope, a 0 slope, and then a negative slope. Bro, it's all pretty great, isn't it? So if you want to determine if a critical number is a minimum, you're going to look to see, does the derivative go from negative to positive? Does it change sign from negative to positive at that point? Again, if you use your hands, and you better do it with me, I can't see any of you, and no one else can see you, so you might as well do it. Negative slope, positive slope. All right, well, I'm going to step back a little bit and show. Negative, positive to negative, positive to negative, negative to positive, negative to positive. Wow. In 16 years of doing calculus, of knowing calculus, I still do that constantly. It's not the only way to do it. That's how I approach it. That's how I keep remembering this. Straight up YMCA type beat. We can totally do this. I am not ready to perform that, but that is a mood that could totally happen. And over here, if you look at this picture, it's a negative slope, it's 0, and then it's a positive slope. Oh my gosh! Ah! It's a thing you can do. This is the first derivative test. So if you want to write it down right now for your own reference, sweet. If you want to write it down later, sweet. I'm about to move on right now, though. Okay, because I want to show you how we're actually going to use this and the kind of response I expect on stuff like this. So here's a typical question that I would ask of you, and I want to show you how I'd expect you to respond. On what intervals is f of x increasing? On what intervals is f of x decreasing? Does f of x have any relative extrema? And if so, what? So here's a function. I want to do all these things. Hey, I notice increasing, decreasing, relative extrema. First derivative test reminds me that I should look at the derivative to help me determine all of those things. So let's get a derivative, bro. Bam, derivative. Well, now that I have the derivative, I'm probably just going to make a sign chart because I can get all the information I need from a sign chart. So I'm just going to make that real quick. To do that, I should find out when it's 0 where I'm defined. So I set it equal to 0. I'm going to factor. Boom. I made this sign chart. I did it really quick. So let me just curate it a little bit. So I set this equal to 0 after factoring. And I got -7 and 5. Both gave me zeros for the derivative. So I drew my sign chart, label it with F prime so I know what I'm talking about. It's not F, this is F prime. Then -7 and 5 both give me zeros. Now I need to test something on each of those intervals to find out. Now what's really nice about the polynomials, especially if you do it in factored form, you can just test each piece and kind of go from there. Let me show you what I mean. So like if I'm going to test something from this interval, so like -7.1. -7.1 gives me a negative here. -7.1 gives me a negative here. Negative times a negative is a positive. Boom, everything in this interval is positive. In this interval, let's see, it includes 0, so I'm going to use that. Put in 0, I get a positive. Put in 0, I get a negative. Positive times negative gives me a negative. Pick a number greater than 5. How about 1,337? That's a solid number, so let's use that. And if I plug that in, I get positive, positive, positive times a positive is positive. So there we go. Boom, sign chart made. So now that we have this, let's look and see how you actually write out the justifications. You're going to do a decent amount of writing on this. And again, if you don't write out the justifications, you aren't earning the points. College Board's very particular about this, so I need to be kind of particular about it. So make sure that I'm emphasizing it for you and you don't lose points because you know a thing, but you didn't write out that you knew a thing. Because that's probably the most frustrating thing about the College Board and the AP test, straight up F, is that when you know a thing and you are confused about how you should show you know the thing, even though you clearly know the thing, they don't think you know the thing and you don't earn the points. And that's a mega rip. So I have 3 questions to address. So let's do that. What intervals is f of x increasing? F of x is increasing on the interval -infinity to -7 and the interval 5 to infinity, since f prime of x is positive on this interval. And really, I should say these intervals, but we'll work out the grammar and all that later. It fit on here better by saying this. I think these made it go into another line and probably went grammatically incorrect, so it could just fit. Boom, I fully answered what intervals is increasing. Let's go to decreasing. It's decreasing on the interval -7 to 5, since f prime of x is negative on this interval. The reason why these justifications are super important is because College Board wants to know how well you know calculus. And in order to show you know calculus, and you do, you need to be talking about the derivatives or something calculus related. So the derivative or antiderivatives, which we'll get to later, but derivatives in particular here. Now we're going on to the third question. Does f of x have any relative extrema? And if so, what? Well, x equals -7 is a maximum because they will ask you these questions. They'll ask you on what intervals is f of x increasing? What intervals is it decreasing? And justify your answer is what they'll do. So I didn't write justify your answer, but that's the idea. It's literally going to be that. It's not going to be like, analyze this and tell me things. They're going to be a lot more direct. And as we go a little bit later in the year, we'll probably do some more free response practice. Right now, we're just getting you used to AP language by doing just tons of multiple choice. Eventually, we'll spend more time on some free response stuff because it's important to spend time on those. It's just we haven't yet because most of the things we haven't. Most of the questions have a whole lot of things going on, and we need more information before we're ready for that. Did I do it? I'll see if that helps. Sorry, I'm trying to blow air out my ears. So F, it's maximum because it changes from positive to negative at this point. And you can see that positive to negative. And again, if you don't remember, positive, negative. Maximum. So F equals 5 isn't minimum because it changes from negative to positive. Straight up minimum, bro. Everything in pink here, that's a full justification for a question like this. You could write more. You really can't write less. This is like the minimum you could write for something like this. All right. So that I showed you how to make a sign chart. Another thing you could do to your sign charts, which might be helpful for you if you get really embarrassed by doing this all the time, which in class I'd be emoting it more, be like, if you don't want to do that with your cameras off, whatevs. But I'm going to do that. And maybe, again, when you're sitting working stuff out, you don't want to do that. Here's what you could do. You could also add some arrows to your sign charts. And then you can kind of see what's going on. So look, it's positive. So let's draw a line going up. It's negative, draw a line going down. It's positive, draw a line going up. And when you do that, you can see, oh, look, it's kind of like a maximum right there. Oh, it's kind of like a minimum right there. Oh. So that's a benefit of doing that and having it set up that way. I think that's it. Yep, that's it. Here's your practice. It's due soon. Keep working on the other things, get them done, turn things in, kind of go from there. I'm going to